Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Chemistry Paper 1 Higher Tier from 2025. Question number 7 is on the topic of energy changes. Hydrazine, N2H4, is a compound of nitrogen and hydrogen. Scientists are researching the use of hydrazine in fuel cells. Table 2 gives information about the use of hydrogen and hydrazine in fuel cells. So hydrazine is a liquid where hydrogen is a gas at room temperature, which means actually this is a bit advantage. Hazards, it's explosive, it's toxic, they're both not good. Equation for fuel reaction cell. Hydrogen reacts with oxygen to produce water, and hydrazine produces nitrogen and water. So that's an additional product, which is nitrogen. Voltage produced. So hydrazine has a higher voltage produced. Catalyst needed for the reaction, platinum, so you don't need a catalyst, so that's also an advantage. Evaluate the use of hydrazine instead of hydrogen in a fuel cell. So hydrazine clearly has some advantages over hydrogen. So let's formulate this answer. First point, hydrazine is a liquid, so it's easier to store and transport, and will take up less space because gas will actually take more space. The second bullet point, both has significant dangers, one being explosive and the other one being toxic. Third point, both produce harmless products. Fourth bullet point, hydrazine produces a higher voltage, which means so fewer cells will be needed to produce the same voltage. So, and you could also say, so the battery will be lighter or smaller, right? And fifth point, hydrazine does not need a catalyst. So costs may be less. And hydrogen uses platinum as a catalyst, which is a rare earth material. So costs are high. So the final point, you need to give a judgment because they're asking you to evaluate. So hydrazine is a better option for a fuel cell. Figure 6 shows a model of the hydrazine molecule. So you have the nitrogen molecules attached to each other with two hydrogen on both sides. Complete the dot and cross diagram for hydrazine in figure 7. Shows the outer shell electrons only. So nitrogen is in group 5. So it has 5 electrons in the outer shell. So let's do the hydrogen. So hydrogen, these are hydrogen atoms. Well, let me draw them as crosses. So hydrogen has a single electron, which means that it forms a covalent bond with nitrogen. So, and this would be, remember, nitrogen can only form 3 bonds. So you don't want to put these 2 electrons in the middle. Give one advantage of the ball and stick model in figure 6 compared to the dot and cross diagram. So the ball and stick, or the ball and stick model shows the shape in 3D, 3-dimensional structure. Figure 8 shows the displayed formula equation for the reaction of hydrazine with oxygen. The reaction is exothermic. The energy released forming new bonds is 581 kilojoules per mole, greater than the energy needed to break the existing bonds. Now remember, you need to break the bonds in the products, and bonds are made here. So what they're saying is the energy released, so the overall energy change is 581. So if I work out the difference, that should be 581. Table 3 shows some bond energies, and they have nitrogen and nitrogen as marked as X. Calculate the bond energy X of the nitrogen-nitrogen bond. So let's write this down. Bonds broken. So we'll have to break one of the nitrogen-nitrogen bonds. So 1 times the nitrogen-nitrogen bond, and 4 times the nitrogen-hydrogen bond, and 1 times the oxygen double bond. So we need to add up all the values for this. And the bonds made is 1 times the nitrogen triple bond, and there's 2 oxygen hydrogen, but there's 2 molecules of it. That means there is 4 bonds, and we added that up here. So 4 times 391, that's the nitrogen hydrogen, plus 498, that's the oxygen bond, plus X, which gives me 2062 plus X. Bonds formed equals 945. That's a nitrogen-nitrogen bond, plus 4 times 464, and that gives me a total of 2801. So energy change equals bonds broken minus the energy in the bonds being made. So that means 581 equals 2060, oops, no, minus 2062 plus x minus 2801. So x will be 158. That brings us to the end of question number 7. I will see you in question number 8.